This naturalrefrigerants.com article is being read by an automated voice. Star Refrigeration installs 290 kilowatt low-charge ammonia system in J D Wetherspoon Distribution Center in the UK. By Polya Pancheva. Published July 8, 2026. Star Refrigeration has installed a 290 kilowatt, 82.4 tons of refrigeration, low-charge ammonia system in a warehouse in Daventry, England for British pub operator J D Wetherspoon. The 192,000 cubic meters, 6,780,416 cubic feet, warehouse stores food, drink, and other consumables and serves as a national distribution hub for the chain. The facility is divided into three areas: a 31,000 cubic meters, 1,094,754 cubic feet, frozen store, a 24,000 cubic meters, 847,552 cubic feet, chilled store, and a 137,000 cubic meters, 4,838,109 cubic feet, ambient store. The facility is operated by DHL on behalf of J D Wetherspoon. The new low-charge ammonia system replaced an ammonia pump circulation refrigeration system installed in 2004. Star said the current system would have required upgrades from 2024 through 2027 at a cost of £400,000. 464,116 euros / $529,620, along with an additional 180,000 pounds, 208,852 euros / $238,329 in projected costs for power, water treatment, and maintenance. Technical details. The manufacturer installed an Azena Freezer 2.0 to complement the already operational Azena Freezer 1.0, which was installed in 2016 and has a capacity of 120 kilowatts, 34.1 tons of refrigeration. The new 290 kilowatt unit provides cooling at minus 22 degrees Celsius, minus 7 degrees Fahrenheit, for the warehouse's frozen store and has an ammonia charge of 220 kilograms. The Azena Freezer 2.0 is air-cooled, which eliminates the associated water costs of the previous system. The system has a lifespan of more than 25 years, and it is expected to deliver a return on investment in under 2 years, according to Star. Star carried out the installation in phases to ensure the warehouse's daily operations would not be disrupted. Simply the best. Star Refrigeration said the system, which has been operating for 18 months, has a specific energy consumption, SEC value, of 19 kilowatt hours per cubic meter per year. SEC is measured in kilowatt hours per cubic meter per year, with the volume defined as the total warehouse's refrigerated volume. This is nearly 17% lower than the UK's best practice benchmark of 22.9 kilowatt hours per cubic meter per year. The benchmark was developed by Andy Pearson, managing director at Star, and presented to the International Institute of Refrigeration, IIR, in 2019. A modern and well-maintained cold storage facility of 100,000 cubic meters, 3,531,466 cubic feet, should have an SEC of 10 kilowatt hours per cubic meter per year for the refrigeration system, while for a 500,000 cubic meters, 17,657,333 cubic feet facility, the SEC could be less than 5 kilowatt hours per cubic meter per year per Star's benchmark. The new unit reduced energy use by 600,000 kilowatt hours annually, resulting in savings of £200,000, 232,253 euros, $264,679, while cutting 123 metric tons of CO2 emissions per year. By the numbers, there were an estimated 5,700 industrial sites worldwide using low-charge ammonia as of December 2025, according to the Atmosphere report Refrigeration, commercial and industrial refrigeration with natural refrigerants. Atmosphere is the publisher of naturalrefrigerants.com. In addition to Star, Australia's Cente Refrigeration Technologies is a notable name in the low-charge ammonia industry. In January 2026, Scantech delivered a 1.13 megawatt, 321 tons of refrigeration, low-charge direct expansion (DX) ammonia system for a cold storage facility located in Melbourne. In 2025, Denmark-based Danfoss touted its NeoCharge system as a shortcut to low-charge ammonia that could save operators of DX systems up to $200,000, 175,000 euros / $199,737 annually by lowering the recirculation ratio in recirculated systems.